Okay, so I'm going to combine lessons 6.2.4 and 6.2.5 just because I need to get you guys caught up with the rest of the class so everybody's ready to take the test this week. So 6.2.4 concentrates mostly on sequences of transformations as we look at the target and success criteria. The target is I can describe a sequence of transformations that proves two figures are similar. Now, Nebraska State Standard says that 8th graders do not need to perform them. You just need to identify and describe them. So that's what this lesson focuses on. So none of these you actually perform, but you're identifying what happens from step to step. The other thing to think about is sequence important when you are transforming one figure to another. So we look at the first problem here of 6-76, and they want to know, do you think these figures are similar? So that was our previous lesson about similarity. Yes, we would say they are similar because their angles are the same, their shape is the same. The side length of B is twice as long as A. So these we would describe as being similar. The next question is to describe the sequence of transformations, whether it's reflections, rotations, a translation, or dilation from A to B. So what does it take to move this figure to this figure? So remember, when we do that, we have to think about, well, it has to be exactly the same to get there. So first we would have to dilate this by 2, because that's what this is. It's twice. The side length here is 4. This is 8, so we know the scale factor is 2. So we multiplied this times 2 to get this big of a figure. And then we rotate 90 degrees clockwise. You could also go counterclockwise, but you're going to rotate from the origin. So you're going to rotate this figure from the origin, and then it ends up here. And then you have to translate 8 units over to the right, so it would be positive. When does your sequence of transformations prove that the figures are similar? When you perform this sequence, they match up perfectly. So when we perform this sequence here, it would match up perfectly here. After we dilated this by 2, rotated by 90 degrees clockwise or counterclockwise, but then you either have to translate to the right or you have to translate up. So that's really what this lesson focused on. It focused on just different steps. Angelina and V, I'm just going to show you what that looks like after they've done that. So she had to first reflect her original shape, her pre-image, across the x-axis, so it would come down. She's going to rotate the triangle about the origin clockwise 90 degrees. So here's your origin. You would rotate it then 90 degrees and then dilate this figure from the origin to with the scale factor of half. So we're going to make it smaller. So we would take all these coordinates and multiply them by a half, and it would make it smaller. So that's what it would look like. These steps will translate the triangle 4 units to the right and then 3 units down, rotating 180 degrees. Remember, when we rotate 180 degrees, it doesn't have to say clockwise or counterclockwise. We're going to end up in the same place. And then reflect the triangle across the y-axis, and this is what you end up with for a figure. So today's lesson is 6.2.5. And our target today is I can apply a strategy to find the missing side of a figure given a pair of similar figures. I can use a strategy to determine scale factor to two similar figures, and I can identify corresponding sides of similar figures. So what happens here, so the bell ringer will be your first slide. So you will have to name the sequence of transformations that took place from this figure A, B, C, D to get this figure down here. I can't read it's A or E, F, G, and H is what I believe it is. So then you'll write those steps in your slide. So then working with corresponding sides. So the corresponding sides, if you remember in the video, one of the videos I have made, when I talked about corresponding sides, we're talking about sides that correspond with a image. So this side would be the corresponding side to this image, and then this side to this image. Hold on, I'm going to get a different paper. This one is my master copy. Okay, so I'm gonna, this would be one course, this side would correspond to this side corresponds to this side, and this side corresponds to this side, and then this side corresponds to this side. And we use the tally marks to show us that we know that this side goes with this side and so forth. Now, we're thinking about, and if anybody's interested in any kind of art or construction design, anything like that, this is where scale factor comes into play. How do we make something smaller to be larger, or how do we make something larger to be smaller than the original? So a lot of you, I don't know if any of you have ever seen the Brady Bunch, but their dad was an architect, and sometimes you would see he would have small displays of buildings that he was building in his house, or if they would have to go to the office or whatever. So those would be scaled down to the actual size of the building that they were building. So then in class, we're going to use this as a partner. We're going to find the scale factor between each pair of similar shapes. That is, what are the sides of each original shape multiplied by to get to the new shape. So if this is our original shape, what did we have to multiply by to get a corresponding side, that number for the corresponding side? So if I look at this corresponding side here of 6 in my original, and this is my new side, but it's the corresponding side, what did I multiply this by to get to 3? So I would think, well, I know that 3 is half of 6, so I could assume that maybe that I multiplied by a half. So then I can see if it works for this one as well. So 12 is the corresponding side to 6. So again, I would say, well, I do know that 12 is twice a 6, or 6 is half of 12. So it would make sense that I multiplied this figure by 1/2 to get the new figure. When I look at this figure, we do not have a whole lot to go on, but I can match up my corresponding sides. I know this one goes with this one, this one, this one, and this one with this one. So the only thing I can tell by this drawing is that my scale, in order to get this to this, well, what did I have to multiply by to get from 4 to 5? That's a little more complicated to think about. So we will come back to that to get a little bit more information. But what the rule derives out of this one is that our ratio or our scale factor is always the new divided by the original. So that's probably the one thing that you need to write down or keep in your mind, that when we're figuring this ratio or figuring out what our scale factor is the new divided by the original. So in this case, our scale factor would be 5/4. And so we can check that. So that means I had to multiply, this gives me my scale factor. That means I had to multiply this number times this number to get this number. So that means I had to multiply 5/4 times 4. And I need to see if that equals 5, and it does. So we know that is correct. In problem 6-87, it was easier to determine the scale factor in A than it was in B. We will work on this as a team task today in class. So it's going to take us into 6-88, where we're looking at 3 students who looked at this figure here, these 2 figures here. Here's our original and here's our new. And they all found different ratio scales or scale factors. And so we're trying to, so we have some questions here. Well, what did they do differently? Do the triangles have more than one scale factor? And if not, show how they are the same. So that's how you will work that slide. Then when we come down to 6-89, we talk a little bit more about the original. This is the B problem in the first problem that we worked, and we're given some more information. Again, trying to find the scale factor. And then there's some questions that will go along with that. Then you're going to have some practice slides with just finding the X or the missing side in each figure. And then you'll have a few more slides that you also are finding more than one variable, but more than one missing side using scale factor. So again, the ratio that you need to focus on is it's always new divided by original. So it doesn't even matter if you choose this one as original or this one as new. It works both ways. So the last 4 slides that you'll do today are these, and you'll make sure you need to identify all the variables. Like this is an X and a Y, this is an X and a Y, this is X, Y, and Z, and this is X, Y, and Z. So that sums up our lesson for today. You'll make sure you watch this video so you have some information about how to perform the problems. I will also probably attach another video on scale factor just so you have an extra resource, and make sure you ask questions in class.